Welcome to Django TDD 101. In this video, we'll explore one of the most powerful techniques in software development, which is test-driven development, and how it applies to building web applications with Django. First, we'll cover the basics of TDD and how it works. We'll also dive into different types of tests such as unit tests, integration tests, and so on and so forth. Next, we'll take a closer look at the benefits of TDD in the context of Django. And finally, we'll explore Django's built in TDD framework and write some tests to develop a user model. Now that you know the basics and concepts of TDD in Django, you can test many components of your Django application. So let's dive in. So, what is TDD? It is a software development process in which developers write automated tests before writing the actual code. And a test in TDD is usually a piece of code that validates the correctness of another piece of code, typically a function or method or a class. The TDD process typically follows these steps. First, write a test. The developer writes a test that describes the behavior they want to implement. This test should initially fail because the code to implement the behavior has not yet been written. And the second step is to write the minimum amount of code to pass the test. The developer writes the smallest amount of code necessary to make the test pass. This code may not be complete or optimal, but it should be enough to satisfy the requirements of the test. Then the process goes to the refactoring phase. The developer refactors the code to improve its design, maintainability, and readability without changing its behavior. The developer runs the test suite after each refactoring to ensure that the change did not introduce any regressions. And finally, the process will be repeated. So the developer repeats the process with another test and starting with step one and so on and so forth. Tests in TDD serve as executable documentation that describes how the code should behave. They also serve as a safety net, ensuring that any changes made to the code base doesn't break existing functionality. And the goal of TDD is to improve code quality, reduce defects, and increase productivity by focusing on the behavior of the code rather than its implementation. By writing tests first, developers can ensure that their code meets the requirements of the test and is more likely to be correct, maintainable, and robust. Now that you know the process of TDD development, let's see how we can refactor our codes. Here are some common tasks that a developer might perform during refactoring. Rename variables, functions, or classes to make their purpose more clear. Extract common code into functions or classes to reduce duplication. Remove dead code that is no longer being used. Simplify complex conditional statements by extracting them into separate functions or classes. Improve the organization of the code, such as grouping related functions or classes together. Optimize code for performance, such as by reducing the number of database queries or improving algorithmic complexity. Improve error handling and logging to make the code more robust and easier to debug. Rewrite code that is difficult to understand or maintain. Add or modify comments and documentation to make the code more understandable. Ensure that the code adheres to coding standards and best practices. And these are just these tasks are just examples, and the specific tasks involved in refactoring will depend on the code base and the goals of the developer. The key is to make small incremental changes that improve the code while maintaining its behavior and avoiding introducing new bugs. During software development, there are several types of tests that can be performed to ensure that the software is functioning correctly and meeting the requirements of the stakeholders. Here are some common types of tests that can be performed during different stages of the development cycle. The first one is unit testing. It is a type of testing that involves testing individual units or components of the software in isolation from the rest of the system. In software testing, a unit refers to the smallest testable part of a software or program. A unit can be a function, method, procedure, or class. This type of testing is typically performed by developers during the coding phase to ensure that each unit is functioning correctly and meeting its requirements. The next type of testing is integration testing. It is a type of testing that involves testing how different units or components of the software work together as a system. This type of testing is typically performed by developers during the integration phase to ensure that the units are working together as expected. System testing involves testing the entire system as a whole to ensure that it is functioning correctly and meeting the requirements of the stakeholders. This type of testing is typically performed by quality assurance or QA engineers during the testing phase. Accepting testing involves testing the software to ensure that it meets the requirements of the stakeholders and is ready for release. This type of testing is typically performed by stakeholders or end users during the acceptance phase. And regression testing involves retesting the software after changes have been made to ensure that the changes did not introduce new issues or regressions. This type of testing is typically performed by QA engineers during the testing phase and after updates or patches are released. Performance testing involves testing the efficiency and scalability of the software under different load conditions. And this type of testing is typically performed by QA engineers during the testing phase and after updates or patches are released. And then the next type of testing is security testing, which involves testing the software for security vulnerabilities and ensuring that it is secure from external threats. This type of testing is typically performed by security experts during the testing phase and after updates or patches are released. Remember that these are just few examples of the many types of tests that can be performed during software development. The choice of test types depends on the specific requirements and constraints of the project, as well as the goals of the stakeholders. Test-driven development can bring several benefits when used in developing Django applications. Here are some of the benefits of using TDD in Django and in general developing any application. The first one is improved code quality. TDD requires developers to write automated tests for their code before writing the actual code. This approach encourages developers to write cleaner, more modular, and more maintainable code. The next benefit is faster development. Although TDD may seem like it would slow down development, it actually helps developers work more quickly and efficiently. With a comprehensive test suite in place, the developers can make changes to the code base with confidence, and knowing that they are not introducing regressions. The next benefit is early bug detection. TDD helps detect bugs early in the development process when they are easier and less expensive to fix. When developers write tests first, they can catch errors before they become deeply embedded in the code base. The next benefit is better documentation. The test cases written in TDD serve as executable documentation of the code base. The test suite can help developers understand how the code works and can also serve as a reference for future developers who may be working on the same code base. And the next benefit is, of course, increased confidence. TDD helps developers feel more confident about their code. With a comprehensive test suite in place, developers can be sure that their code works as intended and that any changes they make will not introduce any bugs or regressions to the code. So it in fact increases the confidence of coding. And the final benefit is easier refactoring. TDD makes refactoring easier by ensuring that the code base remains functional after changes are made. Developers can confidently make changes to the code base knowing that the test suite will alert them if anything is broken. Uh, Overall, TDD can help Django developers create higher quality code more quickly and, of course, with less risk. When practicing test-driven development in Django, developers typically create a suite of tests that exercise various aspects of their application's functionality. These tests are often organized into classes and methods using Django's built-in testing framework. The test case class in Django's testing framework is based on the unit test.testCase class, which is part of Python's built-in unit test module. Here are some of the example classes and methods that might be used in a Django TDD workflow. Setup method, which is called before each test method is run and is used to set up any state that is needed for the test to run correctly. The teardown method is called after each test method is run and is used to clean up any state that was created during the test. These two methods are optional but can be useful in some cases to ensure that each test runs independently of the others. And we need to also define test methods. These are the individual methods that define the tests themselves. Each test method typically checks one aspect of the application's functionality and uses assertions to ensure that the application behaves correctly. And assert methods, which are part of the test methods, these are the methods provided by Django's testing framework for making assertions about the results of tests. For example, assert equal is used to check that two values are equal, and assert raises is used to check that a specific exception is raised. Now let's develop a simple user model in Django using TDD approach. Let's first define our virtual environment, and inside this virtual environment we can install our Django package, and after that we should I believe open another window, enable the environment, and now we can access to Django admin command. Let's create a directory here with the name of Django TDD. Let's go to this directory, and now we can use Django admin command to start a new project inside this directory. We call its name configs, and as you can see, now we have a basic setup for our Django project. And at this moment we can use python manage.py command start app to create a new app inside our project with the name of users. Now we are ready to start the VS Code and start in fact developing our TDD based user model. Let's open the users app, and inside this app we can see a test.py file that we can use to write the tests related to the users app. Let's also open the models.py file, as we will use these two files back and forth to implement the desired user model. And also let's open settings.py file, and inside the installed app list let's add our new app to the list of installed apps, and let's close it. Now we are ready to create our tests. In order to define tests, we should define a class with a name that describes the purpose of this class for testing. So for example, we are testing the user model, so we name the class as user model tests, and it extends or inherits from Django's test case class. Now we have a class that we can define our test methods inside it. Now let's define our first test method. As you know, each test method starts with the keyword test, and the rest of the name of the test method describes the purpose of the test. For example, we define a test for checking the fields of the user model, or to check if the user is created or not. So we name it as test user creation, whatever you prefer. And inside this method, we can define uh, how we want to test the creation of a user. For example, I would like to assert if this user has a field, has a name field, and I would like to uh, be equal to the self name. I will define these parameters later. And also I would like to have a field for my custom user as email, and I would like it to be equal to a predefined email. And of course, every user model should have a password field, so I also need to have a password field for this model, which is equal to the predefined password. And as you know, we have a setup method that is used or that is called before each test method. So in this method, we actually set up the required data for our test methods. And here we define name as test, and also define the email of the registered user, whatever you prefer, and also we define a password for our user. So in fact, we want to create a user that has these three fields, and also we want to check if all the fields of the user has the specified values actually that we have provided. So we need to define a user model. At the moment, we have not yet defined our user model, but in this um, in this section, in this part of code, we should create a user based on a defined user model in this file. So let's save this file, and let's run this test. Python manage.py test. By running this command, Django will start to find all the tests inside different apps and run them one by one. As you can see, it shows that it is able to find the test. So we have one test here, and let's see what's the problem. Yeah, as you can see, it says that the self.user.name is an str object that has no attribute name. That's totally true because we have not yet defined the user model. So let's first go to the models.py file and let's define a custom user here, which is based on Django's model. And now let's import from dot models import custom user, and let's create a user using the custom user. Now let's run the test again to see the result. And as you can see, the same error pops up. The custom user object has no attribute name. So let's define a field for our um, custom user, save it, and let's check the test again. Now, as you can see, our custom user model has a name field, and at this moment, the first assert shows us that the name field inside our user model has no the value, in fact, the value of the name variable or name field inside our user model is different from the name provided here, because in fact when we created this class or this model, we have not provided any value for the user. Let's create a database entry based on this custom user model. So let's create a user with the name of test self.name. So this command creates a user, a custom user for us with the name of test. Let's run the test, python manage.py test. And we see another error which is related to the database, and it states that there is no table custom user. And that's true because we need to create migrations and apply them. So python manage.py make migrations, and now we need to apply these migrations to our database. And now we can check the test again, and now we are in the second assertion. The first assertion was successfully passed. We have successfully created a user with the name of test. So the first assertion was successfully passed, and now we are in the second assertion. So let's create the email field for our model and provide the default value. Let's run the test, and again we need to apply migrations because the email field or email column is not yet in the custom user table. So let's run python manage.py make migrations, python manage.py migrate. Now if we run the test again, the second assertion should pass, but in fact it shows another error because we are expected in this assertion, we are expected that our user has an email which equal to test at sign example.com. Then we need to create such a user. So we provide an email for the user. So let's save it, check it again, and the second assertion was also passed. And at the moment we have a user with the name and email as we provided here, and this command was able to create a user inside the database that uh, has two of the required fields that we provided here. Now the third assertion states that we had to add an attribute, a password attribute for our custom model. So let's add it, password model dot garfield, and let's provide a default for this password field. Let's check it again. So we again need to apply migrations, migrate, and now let's test again. And at this moment we have a password column in our table, but the user that we have created in the setup method has a password that is different from what we are expected to have, because we need to provide a password for our user. So now we expect that all of these assertions should completely and successfully pass. And let's check it again. And as you can see, found one test, ran one test, and everything is okay. So based on this back and forth uh, procedure, we were able to define a custom user for our project. And you can imagine this as a sort of rethinking. So the TDD approach, in fact, helps you to think more and more about your project, and to, in fact, check all the aspects of your code. This is just simple test, but I will show you some codes that is part of a big project, and you can see that how we can define different tests for our real world projects. Sometimes during the TDD development, you may see the error such as the test database already exists. In such cases, you can use the following procedure to delete the database. So we first run python manage.py shell to go into the Django shell, and then from django.db we import connection, then create a cursor, and in that cursor we can execute a drop query to delete the test database. And the test database is has a name, test underline the name of your actual database. So if your actual database name is Django, your test database will be test underline Django. And if you have defined, for example, a Postgres database with the name of, for example, collaborators, your test database will be test underline collaborators. So you can use this procedure to delete the test database and get rid of that error and start testing your project. So at this moment, we have uh, tested a simple model, and right now we can see different parts of the project that we can test. So we can test our model fields and methods. We can test our views, forms, templates, URLs, middlewares, APIs, custom management comments. So every aspect of our Django project can be tested using this TDD approach. And now I want to show you a real world example of test driven development just to see how we can define various tests for different purposes. So let's see. The test you see in this test models.py file is part of the collabshare.dev platform that I'm currently developing, and I use TDD approach to test different aspects of the project to increase its robustness, security, and reliability. In this in this model test, I have written some tests to uh, actually I have defined a collaborator model, and now this file is hold the shows the tests related to that model. As you can see, I have used setup method. I have defined a test create collaborator and check different fields of the model, and you can see different test methods for various purposes. You can also use test-driven approach for developing APIs. In this file, I'm gonna show you the applicability of TDD for test-driven API development. In this class, I want to test URLs of some APIs. I want to test the sign up process, and I define various test cases and check if the API has an appropriate response or not. So in each of these test cases, I send a request to the API endpoint and check the result and analyze the result of the API to check if it is what I have expected. These two files are just examples of how we can use test-driven development in a real-world project. If you need further information about each of these topics, unit testing, Django testing framework, or Python's unit test module, you can go to these three links and increase your knowledge about these topics. I hope the video was helpful, and thank you for watching.